Alright guys, on today's episode, we're talking about tube bending and fabrication accessories you can print at home. Let's go. How's it going, everyone? Welcome back to Make It and Break It. My name's Andrew, and today we're talking about tube bending and fabrication accessories that you can use and make with your 3D printer that will really help you out in your home garage, especially when you're doing stuff like making roll cages, designing engine bars for a bike that's really not designed to go off-road. Both of these projects, and a lot of home garage projects, race car projects, and motorsport stuff that we like to cover on this channel, require you to use a tube bender successfully to either create crash bars, roll cages, new bumper bars if you're doing like a truck, like cattle pusher assembly. And you're gonna want to be able to get the best product possible. There's a lot of tools out there to help you, but most of them cost a decent amount of money. Angle finders and stuff like that. But you can take your cheap 3D printer that you hopefully have in your garage or in your office after watching some of these videos and 3D print yourself some tools to help you out with with a bunch of areas of the process. Hey Joe, how's it going, big bub? Hello, come to say hi. So the processes I talked about involve a lot of measuring and bending and checking, and can require a lot of hand measuring. Joseph has decided to walk behind the motorcycle for some reason. There's nothing back there, Joe. All right, you do you. These processes have a lot of measuring, bending, and check fitting involved with them. And the quicker you can get that stuff correct, and the quicker you can get that stuff right, the faster you can be done with your project, and hopefully, actually, the better your end product will be. So I wanted to show you guys a couple tools that one of them is pretty much required for its process. You need something like it to work on a roll cage, for instance. And the other one is just a really handy thing, especially if you're using CAD models, CAD designs, to design things like your roll cage or your crash bars. So the first one is actually involved with roll cages, and this is one most of you guys should be familiar with, so I'll see you in the car. Hold up, everyone. Quick announcement before we get back to our regularly scheduled nerdiness. We have 100 subscribers. Yeah, we've hit 100 subscribers, and there's at least 100 of you. We actually hit it a couple days ago, and the filming has just been such I couldn't create a specific video until now. There's at least 100 of you that want to watch my stuff on a regular basis. As a thank you for you guys, I did want to create a special merch code for you guys. It's code FIRST100, and you can find it in the description down below, right below the link to our Teespring merch site. So there you can find, you know, awesome hoodies like this one. This one's actually super comfortable. It's the premium hoodie something or other, in the original logo, as well as some different logos and pretty much anything you want from a merch standpoint. And if you buy some of that stuff, it helps support the channel, it helps keep us going, helps keep us doing this stuff. So use the code down below, FIRST100. It's good for about the next week or so. I'll put the expiration date down there, and it'll give you guys 10% off. So if you've been on the fence about getting something to help support the channel, here's an extra 10% your way as a thanks for being here and watching this stuff. So now back to your regularly scheduled programming. So we're in this mess of a car, and unfortunately it's still in my garage, but it gives me a relatively convenient place to show you guys this. So if you're building a roll cage, if I were building a roll cage in this car, first of all, I'd have to strip all of this crap out of here and get rid of everything that's the inside, so I had bare metal, because there's a lot of extra stuff here that wouldn't go on a roll cage. But when you're building a roll cage to an existing car, what you need is some sort of indicating tool to tell you where to start your bends, where to set up your tube bender, and start your bends, and then where they'll end. I think his name is Chris. The fabrication series, TFS, has a really good but long instruction on how to design and build roll cages for like motorsports, and he suggests something that he calls a cheater. And what he's talking about when he calls it a cheater, it's a templating tool. So it allows you to template a roll cage or pretty much anything within a certain box, whatever you're building, a support structure or whatever, using a piece of 90-degree essentially templating tool. So this cheater bar, this templating tool that he uses, is a 90-degree bend on... Joseph, you can't come in here, I'm filming. You don't even like it in here. This templating tool is a 90-degree bend that has marks on it, and the marks are typically somewhere in this case it'd probably be closer to here for his type of tube bender, which I might put up over here. But the marks are the locator for it's basically a mark that can help you set your bend in the right spot. So it's some certain offset based on your machine that allows you to set your bend in the right spot, and then you can use that to move around your cabin. Let's say I need to put a bend here, for instance. So I would be like, okay, cool, this is where my bend needs to go based on how everything's set up. So my mark here tells me where I need to put this piece of tube in my tube bender in order for this bend to be where I want it to be. Now, that works pretty well. And honestly, there's nothing wrong with having that sort of tool, but you may not always have the material you're going to be bending on hand, and depending on the type of material you're bending, that stuff can get very heavy if you're talking about very big sets of pipes or tubes. Pipes are a different thing. So one way to save a lot of weight but still get a lot of the use is to 3D print your own cheater or your own templating tool. Now, this templating tool doesn't actually need to come out of my bender for a couple reasons. One, my bender is a different style than the one that a cheater bar is set up for. So a cheater bar is set up for like the manual style benders or like the rotary ones that bend on the flat plane like this. My tube bender is not set up like that. And so it actually has known offsets from the clamp to the bend that the manufacturer gives you. And it's provided based on the centerline radius or the size of your die. And so what I can do is whatever I'm thinking about bending up something or a specific size of tubing or whatever, I can go, and even before I could get the material, I could go CAD something up like this, where the bend in this material is 6 1/4 inches from the clamp to the start of the bend. So that's what these two long ends, they're 6 1/4 inches from each side. And then you just CAD in the centerline radius of your bend, and you have yourself your 90-degree thing that would come off of your tube bender without ever having to fire up the tube bender, go find yourself some of this new tube or whatever. And I can use this to directly do the same thing as the cheater bar, but now I'm marking to a hard edge here instead of to another mark on another piece of tube. So it should be maybe a little bit more accurate over the long term. And we have another piece of tooling that I think is actually even a little bit cooler, and it uses the same sorts of principles. We're going to go back over to the hypertenere project because it's going to be used more there than it is here. So we're back here in front of our project Hypertenere R6 to talk about another piece that will help you take your CAD model to fully bent parts without the use of a CNC tube bender, which are very expensive and you can't really use in the home garage. Here, and somewhere like here, here, and here in all likelihood, are the places where I'm probably gonna mount the main strength members of this crash cage. And it's gonna run over here and out here and all that sort of stuff. So eventually the idea is to actually come in here and measure this, or probably template it or target it, which is I'll create something here that will go up from the floor, and I'll bolt everything to these spots, and then I can actually like weld and get a target for it. And then I'll go into the computer and CAD up something so that I feel like I'm getting good coverage out of all of my pieces here and protecting the engine as much as possible. But then I'm gonna have to translate that back out. And typically what that means is a lot of measuring of tubing. But if you're gonna do it correctly without a helper tool, there's a lot of extra measuring involved, or a lot of math, and that's just asking to like fudge a number or add in the wrong direction, and then you're screwed. So what I've done here is I've created a tool. This is a layout tool that'll allow you to lay out a CAD modeled bend sequence with both, while only marking via a measuring tape, one set of things, which is the stuff that comes out of your CAD model, which is where your bends start. So what this is it's a sleeve that goes over a piece of pipe. So I'm gonna grab my cheater bar here. Here's my cheater bar. This is sized at 1 inch. So this sleeve is also sized to slide over 1 inch here. It's a sleeve that goes over the bar here, right? So it goes over this bar and it slides along, and it's got 2 holes on either side, right? And so on this one, I've actually CAD'd in and embossed, debossed actually, the words bend and the words clamp. So my machine kind of works like this. So we'll go up from this side. The bender and the roller and all that sort of stuff is right here, and then it'll have a clamp somewhere out forward, right? And then this clamp forces through, and this clamp moving is what actually forces the piece through the bender. So there's that certain offset. What this tool allows me to do is I can go through and mark the specific distances for all the bend starts, and that will go on the pipe itself. So I'll literally just go down and mark each distance on the pipe. And then what I can do is I can just take this piece here, slide it over the pipe, and this distance between these two, actually between these front edges, is exactly, in this case, 6 1/4 inches. So I can then just slide this over, put this mark over the bend marks I already have on it, and mark the clamp locations for each bend. And I can mark it on both sides, and there's just a little bit in the middle here that I can't mark. But once you have it marked on both sides, you can pretty much see where the clamp is supposed to go. So that allows you to easily just slide it along a piece of tube, mark, move it to the next one, mark, all that sort of stuff. And you can actually set up your bends really quickly and easily, and do it without measuring each thing or going and doing a bunch of math and then measuring it out and trusting it. You literally just have to take the numbers that your computer spits out and then run this thing over afterwards and just mark everything. Pretty dumb, pretty easy, but it helps you get a layout much quicker than just taking a measuring tape along your piece of tube and marking and remarking and oh crap, did I do it right? One thing to keep in mind though, and this is something that people get caught up, tube and pipe are not the same thing, nor are they the same size. Because they're designed to do different things. Tube is a structural member designed for structural purposes. Pipe is designed to carry fluid from one place to another. And so 1 inch pipe is not the same OD as 1 inch tube. So if you're bending 1 inch pipe, you need a different you need a different layout tool than you would if you're bending 1 inch tube. Specifically, 1 inch tube is going to be 1 inch in diameter on the outside. 1 inch pipe is probably not going to be. If it is, I'd be a little scared about the pipe for the most part. So do pay attention to your clearances in here. I have it currently set up for about a 20 thousandths diametrical clearance gap. That may be too small. We'll see. I get some 1 inch pipe in here soon, so we'll actually get to test this out for you guys. That's just one thing to keep in mind, is you do have to be pretty specific on your clearances on the interior of this so it slides along without having so much slop that the tool is useless. So anyway guys, hopefully that was a quicker video, and I wanted to show you guys some practical 3D prints for your home garage, because a lot of the stuff that goes off on 3D printers, it really isn't all that practical or requires a very large 3D printer. These ones you could even print in multiple parts and then just glue them together, and it's much the same thing. So I just want to show you guys a templating tool and a layout tool. These things are size agnostic. You can design them for 2-inch, 1-inch, half-inch, 4-inch if you wanted to, and it's really just changing some of the parameters in your CAD program. At some point in the future, I'll probably get my act together and put a Thingiverse or 3D Hubs or some sort of setup with a lot of these files. So if you don't have a CAD program or you're not super confident in your ability to CAD them up, I can put a bunch of these files that I've created down in that section. So if that's created, it'll be in the links down below. Otherwise, thanks for watching, everyone. My name's Andrew. This has been another Make It and Break It YouTube video. If you like this video, hit like. Let me know in the comments down below if these tools seem helpful. I'm really excited to try this one out, and this one, the 1-inch one won't be super helpful, but some larger ones will be here soon. If you like what we're doing in this, channel, we have motorsports builds, cars, motorcycles, a lot of stuff in between. We 3D print, obviously. If any of that stuff sounds interesting, definitely hit subscribe somewhere around here and watch a lot of the rest of our videos. There's some good stuff in there. Again, guys, thanks for watching. My name's Andrew. Catch you later.